In this video, we'll be translating English phrases into algebraic expressions. The goals for this lesson are to translate language in a word problem into a mathematical expression and to be able to write an algebraic expression to compare two or more quantities. All in all, this lesson will help you when you're looking at word problems, and you'll be able to translate the information from those word problems into a mathematical expression, so then you can go ahead and answer the question that is posed to you. We're going to talk about some common words and phrases. We're going to go through the 4 basic operations, and I ask that you write these common words and phrases on your worksheet. So first we're talking about addition. In word problems, you may see the phrases more than, the sum of, increased by, added to, greater than, or plus. And if you see these words or phrases, you're going to use the addition sign when you're writing your expression. Now I just want to point out one thing. You see greater than here. Be really careful with this. Do not confuse that with is greater than, which is an inequality that we use to compare the size of two values. This is just greater than, and we'll see an example where that is used. The next operation we'll look at is subtraction. Some common words or phrases that you'll see are decreased by, less than, and again, don't confuse that less than with the inequality. This is just says less than, does not say is less than. We also have subtracted from, smaller than, fewer than, diminished by, minus, and difference between. For multiplication, we have product of, times, twice, double, triple. And those last 3, those are very specific. Twice, for example, tells you not only that you're multiplying, but that you're multiplying by 2, as well as double. And triple tells you that you're multiplying by 3. Now there are other words that have that same concept that'll tell you what you are multiplying by. And finally we have division. Some phrases for division include divided by, half of, third of, fifth of, or quotient. And once again, when you see these phrases, half of, third of, fifth of, or there are some others, that tells you not only that you're dividing, but that you're dividing by a certain value. So if you see half of, that means you're dividing by 2. Or third of means you're dividing by 3. Now these can get a little tricky as well, because you can write those as multiplication, and that would be acceptable as well. So for example, if you see half of something, you can either write divided by 2, or you can write 1/2 times. So you have some leeway in those cases. Finally, we will have expressions that contain a variable, and when you're writing your variable, you can use any letter that you wish. We often use X or N in these questions, but if you happen to like another variable better, you can certainly do that. I would just stay away from the letter O because it does look like a 0. Some phrases that you'll see are a quantity, a number, a value, or an unknown. And that will tell you that you don't know specifically what the number is, so you're going to replace it with a variable. Okay, so let's take a look at some examples, and you're going to record the results for these examples on your worksheet as well. And if you're confused about anything, you just make a little note on your worksheet and we could talk about it in class. So the directions for all of these will just be write an English phrase, or write each as an English, let me say that again. Write each phrase as an algebraic expression. So we're going to go through 5 of them here. The first one, a quantity is decreased by 7. So we see that we have a quantity, so that tells us right away that we're looking at a variable. The next piece says decreased by, that tells us that we are subtracting, and we are subtracting 7 in this case. So for our first example, we have x minus 7. Again, you can use any variable there. If you had n minus 7, that would be fine. For the second one, quadruple a quantity. So we see quadruple, and that falls in the same category as double or triple. It tells us that we are multiplying, but in fact we're multiplying by 4. So in this case, we have 4 times a quantity, or 4 times a variable. So we can write that as 4x or 4n. For number 3, we have 13 greater than a value. And again, notice there's no is here. So we know that when we see greater than, that means to add. And of course, it wouldn't make sense if we had an inequality symbol in this expression anyway. So if you're really thinking about what the expression is telling you, plus is the only thing that really makes sense here. So we see that word value standing for a variable. Our expression is x plus 13. For number 4, 7/8 of a number. So here we have language that is representative of a fraction, 7/8. When you see that word of, you can always think to multiply, and in fact we can write this as a multiplication. 7/8, oops, let me move that down a little bit further, 7/8 times x. And once again, notice for number 2 and number 4, I'm not using any symbols in between the number and the variable, and that implies multiplication. You can put the dot in there, but it's not necessary, and I certainly would not use the standard x for multiply because it can get confused with x, the variable. Okay, and finally number 5 here, we have 6 fewer than a number, and here you have to be careful, and in fact you should be careful anytime you see that you have subtraction, because the order in which you write the values in the expression must be a certain way. So you have 6 fewer than. Well, when you see the phrase fewer than or less than, you really want to be careful. The order that the values are written in English is not the same order that we write them mathematically. So for this example, we have 6 fewer than a number, and notice that we put our number first, x, then the minus, and then the 6 comes after. So it's really important that you be careful with that order. Okay, so let's take a look at some examples that involve more than one operation, and these you'll have to be particularly careful about. Again, the same directions are given here. Write each English phrase as an algebraic expression. Number 6, a number is decreased by 4 and then tripled. So we want to think about the two operations that are happening. We have decreased by, which tells us that we're subtracting, and then we have tripled, which tells us that we are multiplying. Now, we really need to pay attention to the wording to see which one actually comes first. So, and then it tells us that tripling is the second thing that happens. So we're going to write our number decreased by 4. Let me move that out of the way. So here we have our number x decreased by 4, and then it tripled. So we have the 3 times in front. Now notice I have parentheses here because if I follow the order of operations, just looking at the expression that we see here, I would really multiply instead of subtract. But in fact, from this phrase, we want to have that subtraction come first. So we have to use the parentheses to show that it's subtraction and then multiplication. For number 7, we have 5 less than double a value. So here we're taking a look at 2 operations again. We have subtraction and we have double, which implies that we are multiplying. So here the order is slightly different than what we had for number 6. We have 5 less than double, so it's really 5 less than the product that we have when we are doubling that value. So in this case, our expression looks as the following: 2x minus 5. So it's the subtraction that is happening second after the multiplication. And notice here we don't need any parentheses as we did for number 6 because the order of operations follows exactly what we want to happen in that expression. Okay, number 8 here, we have 2/3 of the sum of a quantity and 8. So this one is also important, 2/3 of the sum. So since that word sum is directly following the 2/3 of, that is what we are multiplying. We're multiplying a sum, which tells us that we want to add first and then multiply. So here we're taking our quantity x, adding 8 to it, and then taking 2/3 of that, and we're using multiplication here for that. Okay, so let's take a look at 2 more examples. Here's where you want to see how we can express two quantities that are being compared. And we'll see this a lot in word problems. You'll be wanting to write something called a let statement, and you'll want to just get the information from the problem, figure out what the variables are, and write any other expressions that relate to that variable. So here we have a sentence here. Angelina is 5 years older than Maria. And what we want to do is we want to describe the two quantities in this sentence. So we have two ages, Angelina's age and Maria's age. Now, I want you to think about whose age you know the least about. Do you know the least about Angelina, or do you know the least about Maria? And in fact, you actually know the least about Maria here, because you have no idea how old she is. But if you know how old Maria is, you can then figure out how old Angelina is. So Maria will be our variable. Well, at least Maria's age will be our variable. And I'm using M here just for Maria. It seems to make sense to sometimes use a variable that has the same initial of what you are representing, so you could easily keep track. So M is Maria's age. And then I can represent Angelina's age by taking Maria's age, M, and then adding 5 to it, because she is 5 years older. So here we have two different expressions, M and M plus 5, and they're used to represent two quantities, but we're using the same variable. Okay, one more example similar to that. Here we have the length of a rectangle is 8 feet longer than half the width. Write expressions for the length and width of the rectangle using the same variable. So I'm going to ask you to pause here for a second and just jot down on your worksheet what you think the expression should be, and then just check back to see what we have. Okay, so hopefully you have written something down on your worksheet. Let's take a look at the expressions that we see here. Once again, we're trying to determine which measure we know the least about, and in this case it's the width, because we don't know what the width is at all, but if we do know the width, that unlocks how to find the length of this rectangle. So here I'm using W to represent the width, and now that I have a variable to represent the width, I can use that for the length. Now the length, it has two operations involved in its expression. We have 1/2 the width plus 8 here. And again, if you go back and read the keywords in the sentence, we have 8 feet longer, which implies that we are adding. Okay, so here I just want you to take a moment and jot down the strategy for describing two or more quantities in the same variable. So first, you're going to determine the quantity that you have the least information about and choose a variable to represent this quantity. Then write the remaining quantities in terms of this variable. And again, we had two examples that we just looked at, but of course, if you want to rewrite that in your own words so that it makes sense for you, feel free to go ahead and do that. Otherwise, that concludes your quick lesson on translating English phrases into algebraic expressions, and I hope you use this as a reference point, but we will, of course, be looking at more examples in class.